So what I'm going to do here is give you an example of how we can work with aggregates. Okay.
Mm-hmm. Yep.
I'm going to go ahead and bring in a design file in here. And I have a 3D model as you see it.
Yep.
And what I've drawn here is a basic shape in here. I have some,
Yep.
Pockets, some simple basic shapes right there.
Yep.
Now, to be able to program these, you need to use a tool that's at right angle to it, right? You can't basically,
Yep.
uh, rotate the piece because you wouldn't have enough Z travel on the machine. So that's where you're using like an aggregate head. So the way we do that is we define this as a 3+2 machining operation, or also known as indexed 5-axis setup. So we can orient the coordinate system so that the Z-axis is normal, or the tool axis is normal to these faces, the side faces.
Okay.
So we define the machine tool as a 5-axis, and once we define the machine tool as a 5-axis, we would be programming toolpaths. So here I've defined the machine tool as, and this is all can be saved to a knowledge base. So when you load a knowledge base, it loads the machine configuration in automatically.
Okay.
Now in the workflow, if you need to do any programming for the top face, you could do, programming like a profile cut to square out the part, you can do that. But then, we've already done that in the previous example. But let's go ahead and focus on how we could program these pockets. So what we do is we add, or we create a setup, and we click on a new setup in here, and we can set the coordinate system to be oriented so that the Z-axis is normal to one of these side faces. So you can use these controls by selecting a surface. I can pick a surface, and the Z-axis would be set normal to that.
Okay.
Once you define the Z-axis to be normal to it, you could program any of your 2-axis or 3-axis machining operations in here. Even if you had a cavity where the floor is not, the bottom of the cavity is not flat or planar, so you can still do a 3D toolpath. So that's the beauty of it. So it's called 3+2 machining, where you're locking the two axes to a plane, and then you're programming a 2 or a 3-axis operation. So now I have a pocket operation defined, and the pocketing operation is using an end mill, half an inch, and you're basically programming these pockets in here by defining all the parameters.
Okay.
So the pocket is now programmed. I can go to the Simulate tab and select the play button, and that shows the tool axis in the rotated plane, rotated orientation.
Mm-hmm.
So I could go from one setup to the next setup in here, program features. So this is known as indexed machining.
Okay. Yeah.
So you can program it from different orientations. Now once you have these programmed, we could post these with the Z-axis output in here as well. So we have posting capabilities that would allow you to post those Z-axes in the output. And I'm going to show you the post-processing in here as well. So I need to select the post-processor, and I'm going to do that in just a moment. And so the post, we need to provide you with a special post which would allow you to post them in this format. So now I'm going to right click and then select post all. I'll just post it to my desktop, and you'll notice that it outputs C0. Then you got the C90. Okay. You have your C180, and then C270.
So that's the amount the axis has been rotated, essentially.
Yes. And
yeah. Okay.
After the axis is rotated, it takes care of the transformation of your coordinate system in here. So for example, when you're processing the toolpath on this front side, technically you're moving the cutter in and out in the Z-axis, but when you look at it at the machine, it's the Y-axis that's transforming in and out, right? So our CAM system takes care of all the transformations, back to the world coordinate system. So that's all taken care of in the CAM programming. So the user does not need to do any additional transformations.
Okay.
So everything is computed.
Yep.